Good morning everyone. I am Tanushree Dalai from Civil Engineering branch. So in the previous class we discussed about the elastic constants. So today class we will start with the next elastic constant, which is your bulk modulus. So it is says that when a body is subjected to mutually perpendicular direct stress which are alike and equal within its elastic limits, the ratio of direct stress to the corresponding volumetric strain is known as a constant. This ratio is called as bulk modulus. It is expressed as capital K letter. Okay, the capital K represents the bulk modulus symbol and its unit is same as the unit of stress, Young's modulus and modulus of rigidity, which is your megapascal or Newton per mm square. So remember one thing, 1 Pascal equal to Newton per meter square and 1 megapascal equal to 1 Newton per mm square. So in the simple way we can say that the bulk modulus is defined as the ratio of direct stress to the volumetric strain. Okay. So always the bulk modulus we can measure within its elastic limit as we measure the Hooke's law. Okay, in the Hooke's law also we have to consider the structure in elastic limit. So it is most important, you have to remember this. Okay. So next one is your, what do we mean by volumetric strain? Because here we have to divide the volumetric strain. So what is that? So volumetric strain is nothing, it is the ratio of change in volume to the original volume under normal loading condition. Okay. So while you apply a load to an object or to a body, then the body should be deformed in all its dimension. That means in its length, in its breadth, in its width. Okay. So that's why here you have to divide all the strain deformed in a body. Okay. So next is your Hooke's law. So in the Young's modulus, we discussed about Hooke's law and it is a 2-mark question also. What do we mean by Hooke's law? So you have to write, it is says that when a material is loaded within its elastic limit, stress is directly proportional to strain. That is, your stress is denoted as sigma is directly proportional to epsilon, or it is the symbolic form of strain. So here your stress is directly proportional to strain. Okay, you can give a symbolic representation of strain as epsilon or E, small e. Okay, you can take anyone from these two. So while you convert the proportionality symbol into equal symbol, then we have to put a constant over here, so that we put the capital E here. That means the stress equal to strain multiply into a constant, and this constant is known as your Young's modulus or modulus of elasticity. From this equation we find out the value of Young's modulus. Okay, so what is the value of Young's modulus? It is the ratio of stress by strain. Okay, so now comes to the relationship between elastic constants. So we have 4 kinds of elastic constants. So one is your modulus of elasticity, then modulus of rigidity, then bulk modulus, and another is your Poisson's ratio, which is denoted as mu. So, the 3 and the 4 elastic constants, they establish a relationship in between them. Okay, so what are these? So first of all, the relationship between modulus of elasticity and bulk modulus is known as your capital E equal to 3k bracket 1 minus 2 mu bracket n. Okay, it is the relationship between E and K, that is your modulus of elasticity and bulk modulus. Then the second relationship is in between elastic modulus and modulus of rigidity. So what is that? Your capital E equal to 2g into 1 plus mu. Okay, so it is the relationship built up between E and G. Then the third relationship is built up in between Young's modulus, K and G. So what is that? It is capital E equal to 9 kg whole divided by G plus 3k. Okay, that means when you derive this equation and this equation, you can get this solution part as 9 kg by G plus K. Okay, so next one is your the relationship in between bulk modulus and rigidity of modulus or capital G. So here the relationship is mu equal to 3k minus 2g whole divided by 6k plus 2g, where your k is represent the bulk modulus, capital G represent shear modulus or modulus of rigidity, and capital E represent your modulus of elasticity or Young's modulus. Then individually Young's modulus and bulk modulus and modulus of rigidity are related as this formula, which is your capital E equal to 2g 1 plus mu, and another formula which is built up in between your capital E and bulk modulus, which is your E equal to 3k into 1 minus 2 mu. So, the derivation of relation between elastic constant. So, we can derive the elastic constant relation by combining the mathematical expression relating terms individually. As I told in before, like your Young's modulus have two formula. Okay, one is your relation between E and K, which is this formula, and another is your the relation between E and G, which is this formula. So by equating this value equal to this value, we can get this value. Okay, so Young's modulus can be expressed using bulk modulus and Poisson's ratio as this formula. Okay, similarly, the relationship in between E and G, which is your capital E equal to 2g into 1 plus 2 mu. So by combining the two above two equations and solving them to eliminate Poisson's ratio, we can get the relationship between Young's modulus, bulk modulus and modulus of rigidity. Okay, so which is your E equal to 9 kg by G plus 3k. Okay, so it is all about your elastic constants and the relationship between elastic constants. So you may ask in the semester exam the relationship between elastic constant. So you have to write the elastic constants formula, its definition, and then you have to derive the equation or derive the formula and relationship in between E, K and G. Okay. So thank you so much. We will discuss remaining part in the next